next we'll look at some of the frame relay terminology that is being used. Okay, this will be the term that the ISP will actually use when you want to subscribe to frame relay with them. Okay, so number one is the access rate of the port speed. Basically, this will be the maximum speed that you can go when you join the frame relay network. Okay, next will be the committed information rate, which is the speed of or the bandwidth of the data that you subscribe to the ISP. So this information rate is the amount of data that the network receives from you, and the service provider will guarantee that you as a customer can send data at this rate. So if you send data at this rate or below this rate, they will accept all the data. Okay, one advantage about frame relay is that because it's a shared network, so not the entire capacity is being used. So the ISP will normally allow you to exit your committed information rate, and this is called bursting. So they allow you to use those unused capacity burst beyond the committed information rate at no additional charge. So this is considered as a bonus. Okay, so this bursting is called the committed burst information rate, which is a negotiated rate. So you will tell the ISP, let me burst up to a certain rate, okay, at no additional charge. So the committed burst information rate is a negotiated rate above the CIR, which you as a customer can transmit for a short burst. Okay, so as and when your network bandwidth permit. Okay, access burst means that you have in fact used more than the committed burst information rate up to the maximum access rate of the link. Okay, this is normally non-negotiable. This is actually a calculated value, and if you burst beyond this committed burst information rate, okay, the packet will likely to be dropped. Okay, the last one is called the discard eligible. It's actually a flag inside the frame relay header. Okay, if we go back a few slides, or the start at the beginning of the slide where we look at the header, one of the flag is called the DE flag. Okay, so this flag will be turned on, okay, if you send information or you send data above the committed information rate. So this is to tell the frame relay inside the cloud, okay, that this data can be discarded because they have been sent, okay, above the committed information rate, and they will be discarded if the network is congested. Okay, let's go through one example. Okay, for example, okay, now you are subscribed to frame relay here, so the customer is paying for the following. So at access rate of 64 kilobits per second, so this is the maximum speed that you can connect to the frame relay cloud. Okay, so this is the access rate. Okay. Then we have two virtual ports, or they are identified by the two DNICR number 102 and 103. Okay, what's the speed that the customer is subscribed to? Is subscribed to a committed information rate of 48 kilobits per second. Okay, so these two DNICR number, or the two virtual port, one is subscribed at 32 kilobits per second, the other one is at 16 kilobits per second. Okay, when you add these two up together, this becomes the committed information rate of 48 kilobits per second. Okay, so using the example, okay, the access rate, the maximum speed is 64 kilobits per second. So this is the maximum speed that can go. Therefore, it should be higher than the combined committed information rate 32 bars 16, which is your 48 kilobits per second. So under normal circumstances, your two permanent virtual circuit can send data within these two rates. Okay, you will be able to go through. Okay, because it's a shared network, so they allow for bursting when there's access information or access bandwidth being available. Okay, so the frame relay ISP will allow you to burst beyond this CIR for free. Okay, so bursting allows your devices to use the additional bandwidth at no extra cost if the other device that's sharing the same frame relay cloud is not using them. Okay, so this is one example of bursting. Okay, similar example, two DNIC number 102, 1032 virtual ports. This is a committed information rate. Okay, then you will negotiate with the ISP saying, let me burst. Okay, this you feel that sometimes may need extra bandwidth. Let me burst to 48 kilobits per second for this. Okay, let me burst to 48. For this, I do not need any bursting, so 0 kilobits per second for the CBIR. Okay, so for 102, I allow additional bursting of 16 kilobits per second to make it from 32 to 48. Okay, so frame that is sent within this CIR will not be eligible for this cut. If you send it above, they will mark the DE flag to be equals to 1. So if the network is congested, I will discard it. If you burst beyond this 48 kilobits per second, okay, then they will be likely to be dropped. Okay, this will be your BE range. Okay, your BE range. Okay, how do we calculate this BE range? Okay, so this is an example of the 32 kilobits per second. The DNS number 102. Okay, so 32 kilobits per second is your CIR. I allow you to burst additional 16 kilobits per second to go up to 48. Okay, and if you burst beyond and go higher than 48 and to a maximum of 64 kilobits per second, so this is the BE value. Okay, you can go even higher by 16 kilobits per second from the CBIR. Okay, but frame that is sent here will be likely to be discarded. Frame that is sent here will have the DE flag set to 1. Okay, frame that is sent here, okay, will not be discarded because it's within the CIR. Okay, so that's the explanation of CIR, CBIR, BE, and bursting. Okay, the final part is on frame relay flow control. Okay, if you remember earlier slide, we mentioned that there's a few flags that allow for congestion control inside frame relay. Okay, so they are the FECN, BECN, and DE, discard eligible. Okay, so what are they used for? Okay, they are used to let the router knows that if there's congestion, the router should stop transmission until the congestion is reversed. Okay, let's look at how this flag have been used. Okay, the FECN is set on every frame that the switch receives from the congested link. This is to tell the downstream device of the congestion. While the BECN is set on every frame where the switch plays on the congested link. This is to tell the upstream device of the congestion. Okay, let's look at some examples. Okay, let's say this is a router, a switch, and a switch, okay, and a router. Okay, let's say as this router sends a packet to here, and this link is congested. Okay, this link is congested. Okay, what this frame relay switch will do is when he receives, okay, the frame from this congested link, so when he receives the frame, he will then set the FECN to be equals to 1. We will set it here, FECN equals to 1, to tell the downstream device, which is here, that I have a congested network here. Okay, so expect delay from or even missing packet, okay, because there's a congestion. Okay. So when is BECN being used is, okay, so the packet come back, so this is a reply packet. Okay, so this is a congestion link. So for this switch, right, okay, when before he put the frame on the congested link, okay, he will also set the BECN to be equals to 1. And then send it back here and send it back here. This will tell the upstream device, the device that is sending data to this direction, warn him that we have a congested link here. Try to reduce the packet you are sending. So the BECN and FECN will inform the two routers we have a congested link. Slow down, reduce the flow of the frame until the congestion is clear. So in period of congestion, okay, to also help to ease the congestion, okay, the frame relay will decide whether they want to drop packets or not. How do they decide? Okay, if the DE flag is not set to 1, okay, then that means it's not exit the CIR, the frame is passed. Okay, if the frame exceeds the committed information rate, the D flag will be set to 1. If the frame exceeds the CBIR, it will be discarded in term when the link is congested. Okay. So when the network becomes congested, the DCE device will start to discard frames, so that they do not allow them to enter into the network. This will help to ease the congestion. Okay, so that's all for frame relay. So you'll do this frame relay exercise in the lab to help you understand on how to configure frame